Hi, this is Saurabh. Welcome to the Naked Product. Today we are going to talk to somebody I really admire because I met him recently, like in a year back in Lucknow, and he's somebody who's basically been doing AI for like a decade or so. So let's say hi to Harsh Joshi. And before we deep dive into AI, let's hear a little bit about who Harsh is. Give us a little background about who you are, where you come from, what have you done so far, and stuff like that. And then we'll move on to the questions.
Thank you for having me in the Naked Products RG. Pleasure being here. I have spent over a decade working in AI. I started working, volunteering with Indian Council of Agriculture Research, Central Soil Salinity Research Institute. That's where I started working with this NGO called NEFORD, right? Back in 2014, right? So at that time, auto encoders, everything was very new. Right? From that time, we were building our own drone systems, our own embedded systems, trying to do soil profile, agriculture profile, and all those things for precision agriculture. After that, I went on to build smart zones with Arjun and an entire team over there. Right, so I led the product development, came in as a founding, product development lead or whatever the titles, and actually built this whole foundation of DJoule and Joule Mind and all of those things, which essentially we're applying AI and IoT to streamline energy operations, right? How do you save energy consumption, particularly optimizing HVAC profiles in commercial buildings, right? And then after that, I spent a year doing art consulting with different bodies, different areas, uh, primarily helping them kind of figure out their AI strategy, do quick POCs, take it off the ground. Then I did a short product stint at Zenoti as a product manager, right, where it was already Series C by that time. I helped them kind of move to their Series D journey, creating this whole new, market for small medium businesses in US and Canada primarily. And then after that, I built my first venture, Sachet, which was again doing fundamental embedded engineering and AI on emergency response, right? So working with jewelry shops and Android apps, things like that. To essentially, how do you bring emergency response in a timely manner, right? So that was the problem statement over there. Then I kind of started, dabbling in this whole DAO and blockchain domain, and that's when I built my first startup, DAO Studio, right? Uh, DAO Studio had a very rough journey, right? We had a lot of setbacks, but we kept playing. And by the way, that was 2022 had already happened. So anyone who was anyone's mom wanted to put ChatGPT API inside of a toaster or an oven, that craze had already started right towards the end of 2022. And we survived in basic consulting and stuff. And then after that, I took small roles like as a head of product at Specmatic, and then as a VP of engineering at Occasion. Right now, I'm leading the whole product management side of this decentralized AI cloud platform, Aeon. Right, so it's a startup, and we've just set up our team in Bangalore. So that's going great.
Outstanding, outstanding. So for folks who don't know, Harsh is an integral part of a group I call the Indian Product Group. We have been running this group for the last 4 years. It has some of the top leaders from product spectrum across India, across the world and all. And all of us look up to Harsh when it comes to artificial intelligence because, as much as I would like to say that I know about AI, I know nothing about AI. So if I were to ask a question about AI, I have to basically, Harsh becomes the soundboard and I have to basically ask him about AI and then get a validation. But having said that, I think ever since generative AI appeared on the spectrum, right, and everybody's talking about generative AI, such as ChatGPT came and then Claude came and everything, there is also a lot of enigma around generative AI and these models, especially, right? Because I don't think I've heard folks talk about models, normal folks in the product folks, operation folks, marketing folks. Everybody's talking about large language models, large reasoning models, and stuff like that, right?
Yeah.
But as you go inside that, like I was watching a deep learning video yesterday, and as you go inside that, you find a lot of math and code. It's like a black box of math and code, right?
Mm.
So if you were to demystify a bit of that to, let's say, a very bright 15-year-old guy from a school,
Mm.
what would you tell him that AI engineering, what is it all about? What is this enigma surrounding AI engineering?
Yeah, this is a very controversial and fascinating topic because see, most of the time these technologies have a way of finding their way into marketing hype cycles,
Right.
and then things get blown out of proportion. But like if you ever uh, build any AI system, right, it's not very different than building a regular software system. Only thing is your perspective on how do you guarantee an output changes because your guarantees on input processing start changing, right? So essentially, I mean, we all do modeling in our daily lives, right? Like, for example, if you are budgeting your monthly income, hey, this much goes to grocery, this much goes to, that's also modeling, right? And just how it happened with blockchain, like people blew it out of proportions, but essentially you're building a ledger that's immutable, right? So it doesn't really matter. In old days we had munis in India, right? So they wrote in register, we gave this much money to this much, right? That was also a ledger. Then people became smart. We had new technologies. People started writing things in Excel. That also was a ledger only. Then people become even smarter. We were like, okay, we'll write SQL, right? That's also a ledger. So you kept changing things and you came up with fancy ways to solve one particular problem. Fundamental stayed the same. That's the same thing with modeling as well, right? So even if you look at AI systems, what you are essentially saying is, I don't want to deterministically encode functions and parameters that will translate A into B, A being your input, B being your output. What I'm going to do is I'm going to create certain boundaries under which this system has to operate, and then I'm going to train it, right? And then based on my input, my output starts translating, right? So even AI also has like a very big spectrum, and people have been doing AI since I don't even know, like 40 years back also, right? 40, 50 years back. Because again, every time you build something non-deterministic, when you're modeling it, that falls in some dimension of artificial intelligence, right? So we had models like, and finance and other domains have been using it extensively. Like logistic regression is bread and butter of most models. That's also AI, right? Like it's a very specialized machine learning approach,
Right.
right? And then then these systems evolved. So back in 2010s, when I was first getting into this whole AI stuff, we used to use this library called scikit-learn and scipy in
Right.
Python, right? A lot of things, decision trees, ensemble models, random forest, all of those things, they are also AI, right? What's happened, what's fundamentally changed in the way people have now put model at the forefront is all of these model were classifying something, right? So if you had a set of input, you could classify it or you could extrapolate it, right? So a common person did not see much utility into it, but around 2018, when this Ashwini's this paper on attention is all you need came out, right? And that's when you started seeing, okay, if I can classify things, why can't I classify the probability of what my next token would be? And if I can classify that probability, then I can start taking those tokens and putting it back in. And that way, sequentially, I can start generating
But
entire paragraphs.
didn't that actually come from like with the back propagation paper that Hinton wrote like probably 10 years back?
So, back propagation essentially is just one technique how you can kind of move the weights through this network that
Yeah.
it's essentially a big graph, right? With activation functions and weights that are just encoding the way
Plus
the
bias.
system is learning, right?
Right.
So what that is essentially doing, think of it this way: it's a compression algorithm.
Hmm.
The best way to understand what is AI doing, it's fundamentally a compression algorithm. right? So you had, even when video editors and photo editors use, so you all see this JPG image. What is JPG? It's a joint photographer expert group, right? That whole protocol. It's a compression algorithm, right? See, some compressions are lossy, some compression are
Lossless.
lossless, right? AI in particular is a lossy compression, the way we look at it right now, right?
Right.
So you give it a lot of information. These weights and these graphs kind of evolve through different mathematical techniques. One such technique is backpropagation. There are many other ways to do that. And what that does, it compresses the whole event space or the data space that you give to this model, right, into certain weights, biases, and how these activation function kind of trigger those things, right? But in the end, you're still classifying something, right? What you are classifying in these generator systems is the probability of my next token. So essentially what you're saying is, hey, this is my vocabulary. All of these particular words, grammars, and tokens could exist. Now, if I gave you this particular set of input, what is the probability in this entire vocabulary this word would happen? And the highest probability token kind of gets put in, and then you add it to the original sequence and pass it back again. Then you do it and you keep doing it recursively, and eventually what you're doing is you're generating a whole sequence. Now, the moment you started generating data, right, this changed a lot of things, because if you look at uh, this whole notion of how humans interact with one another, right? We generate a lot of stuff. We communicate, right? Communication is an inherent generational. It's a variant of generational properties, right? And that opened up lots of doors. Initially, with like quick gimmicks. Okay, hey, you can have like a quick fun joke with ChatGPT, but later on, like a lot of real use cases started emerging, things that you couldn't do, right? Because if you can generate tokens, then you can arguably generate any sorts of tokens. These tokens could represent images, these tokens could represent video, audio sequences, and now the landscape is very different, right? So that fundamental shift of, if I can classify things, what do I do next with that classification? That was the whole turning point, and it happened very slowly between 2018 to 2020, right? In the research community it was happening, but it was not mainstream until that whole chat gpt movement came, and anyone and everyone's mom was like, okay, I now can talk to AI, I have a model, right? But in the end, these are pretty standard systems. They've been used a lot. Every time you order something from Amazon, every time your YouTube say watch this new video came out, everywhere you see there's AI. So these things are not new, and the modeling techniques have evolved, but at its core, it's still one big statistical system. And what's changed is, if you uh, you know so the best way to look at it is, you look at it in interval of 5 and 10 years, right? And what you'll see is, every 5 to 10 years, what's happening is, you are 100xing the amount of data that you are kind of putting in this training loop, and you are 100xing the number of parameters inside of this model, and that's changing the game, right? Obviously, the implied property is, if you have so much data and so many parameters, your compute is also 100xing. Only thing, recently in the past 1 to 2 years, what has happened is, this 100x function has started happening every few quarters, right? So now this has gone in an exponential loop. So, and there's this whole area of scaling laws and all of those things that have come up, but in a nutshell, nothing has changed. It's just like the scale at which we have started doing this, and the conviction that the common public has started having in these systems has changed, which has kind of created a cycle of more of these systems. And so now we're in a territory where everything is probabilistic.
You know what is so ironic is that someone who actually comes up with a theory doesn't get to make anything out of it.
Yeah.
So Xerox Spark came up with the entire idea of GUI, which was taken by Apple and subsequently Microsoft, right?
Yeah.
Then you had IBM come up with the relational database paper, which was
Yeah.
basically taken by Oracle, and they came up with their own database. So similarly, this Vaswani's paper on
Mm.
attention. It was actually consumed by OpenAI, who came up with ChatGPT, faster than Google could come up with the Gemini model.
Yeah.
So it's interesting. But now moving on, now that you've spoken a bit about AI engineering, let's try to tackle the important issues. So there's a lot of myth around who is a data scientist, who is an AI engineer, and who is a machine learning engineer. Right? Everyone keeps talking about the same. Every forum, every platform I'm part of, it could be a product platform or a technology platform or any other platform per se.
Yeah.
People are kind of confused about these positions because they
Yeah.
seem almost same. I mean, the lines are blurrier in terms
Yeah.
of what these positions are. So if I were to ask you that question, then can you break it down in a way which becomes easy? So let's do the Feynman way, right? Let's
Yeah.
make it so easy to understand that a 5-year-old can understand the difference between what a machine learning engineer does, what an AI engineer does, and what a data scientist does.
Okay.
How would you explain that to a 5-year-old guy?
Okay, so for a 5-year-old guy, this is interesting. But okay, I'll take a different spin at it, right?
Sure.
So I think fundamentally, right, like as human beings, like we have this ability or innate desire to put labels on anything and everything, right? It gives us a sense of purpose. It gives us a sense of tribe, right? And that's where these things become very tricky because in the end they're all the same, right? Uh, like it's like you put a label to make operations easier because you want to classify every time. You don't want to go in those hypotheticals and generate discussions. So to make things operationally compartmentalized, you just put labels, right? And that's where those boundaries become blurry. But if you have to understand these profiles, you just have to understand what is the life cycle of an AI product, and that makes things very simple, right? So someone,
Or let me put it in another way. Because this is a product discussion, this is a product podcast. What are the in the new AI utopia,
yeah,
right? Let's say corporate utopia. What are the different kind of positions that exist or may exist in the next 2 to 3 years?
oh yeah, that's a very interesting thing because one area that previously was very frowned upon, or I would say not taken very seriously, egos or whatever you want to call it, was
Right.
this support engineer role, right?
Yeah.
Uh, more and more today, you will see this new title of forward development engineers, FDE, is coming up, right? And it's it's one of the primary areas that kind of makes or breaks.
Or is it a way to optimize costs?
I would say though so it kind of comes from this fundamental point that AI is not mature right now. Okay, so for any practical, real economical use case, there is no plug and play solution that exists at this moment. The way technology is, the way technology is distributed, and the way we are consuming it,
Right.
there is none. Which means, regardless of how you brand it, right, whatever way you figure out to market it, to make it really valuable, you will have to do some bespoke customizations. And this is only possible with this one very this area that's coming up, which existed previously, which was of support engineers. These are folks that uh, take product from my company and they go to your company and they're like, okay, tell me what's your problem. I understand this problem. Okay, this exists. That means I'll have to change this. Okay, I changed this. This is working for you. It's not working for you. I go back to my engineers. I understand. Okay, can we add this thing so that I can customize it like this for 10 other people, right? So that FDE role cuts at the intersection of product. It cuts at the intersection of sales and pre-sales cycle. It cuts at the intersection of engineering, and that is very important to tie the loose end, right? Because it's very easy to say, okay, we built this, rest is just integration, but that's where 99% of the edge case will occur, right? So giving that finesse, that's the ownership of FDs, and that's one of the primary roles that would come up and is already coming up, and it's one of the highest paid roles now in SF if you look at it, right? Another area, if you look at it, the boundaries between growth and product are blurring, And likewise, the boundary between engineering and product are also blurring, right? And if you start looking at it, the fundamental role is who is a builder, right? And who is a strategist now. That's the only two boundaries that exist now. All those titles that we used to have, say 10 years from now, past 20 years from now, and past, they become more and more meaningless when you look at the way AI empowers you, because AI empowers an engineer to look at the blind spots, right, with these generative tools. And that's one of the primary roles of product manager, right? Because product manager is there not to build the best engineering intellectual masterpiece, right? Is there to serve a very specific problem for the customer, which a good engineer, see, the better the engineer is, the stronger the bias are, right? That's always the case, right? And one of the key roles of product manager is to take away the bias, right? Two customers are saying this, but all 100 customers, what do they really want? 10 engineers really want this, but what do most of the folks want, right? So you have to cut through the bias. And now that ability is slowly shifting towards engineers, right? Engineers can do that if you have a really good strategy around it. Now, the second thing, particularly if you open up engineering as a bucket, there, so you had DevOps and SREs. That doesn't go away. That in fact becomes more and more important here, because now you're dealing with even massive volumes of compute, right? More dependencies on these servers, more dependency on these servers being decentralized. So DevOps and SRE, on the contrary to all the media hype, they are and going to be even more critical roles coming forward, right? With AI, cybersecurity is a big concern, right? Because AI is a leverage. And leverage does not distinguish between, hey, you are an engineer, you're a good guy, you're a bad guy, you're a product guy. It's a leverage for everyone, right? So even for bad actors, it's a leverage, right? So DevOps is still going to be there, and it's going to be even more important. But then the boundary between, are you a machine learning engineer or are you a software engineer, that's gone. It doesn't matter if you're a machine learning engineer or you're a software engineer. You understand your data structures, machine learning algorithms are just another data structure. Just kind of understand it, move on, and just build this thing. That's the way things are, right? The boundary that exists over there is, are you a machine learning researcher or not? Because a researcher is primarily responsible for something that's going to come out 5 years from now, 10 years from now. An engineer is responsible for something that's coming out in next sprint, right? What's being shipped next week,
Right.
that's what they look at, right? So the distinction now is more on those domains, because a researcher is now saying, hey, okay, this thing works, but with these constraints, what if I played with this? Can I come up with a theory and kind of demonstrate it predictably so my engineers can productionize it, right? So those are the only three boundaries. Now, depending on, you're applying it internally, you're a data scientist. You're applying it externally, you're a FDA. You're building it as a tool, you're just an engineer. So the classification is like so. Because if the old labels came from this idea, okay, there was a lot of data, there were only two people who could write AI code, I'll call them data scientists, but how do I give them all of this data in a clean format so that they can do this analysis? All those things don't matter, right? Because now even an engineer, machine learning engineer, have a blurry boundary. So essentially the jobs to be done is get the damn data. How do you do that ETL? How do you clean it? How do you push it into a model? What insight do you want from model? How do you productionize that insight? So all of these titles are more around your use case, but on a fundamental level, you're either a product strategist who's looking at the product, who's looking at the growth and all of those aspects, or you're an engineer, and that's it. That's as is, right? And then either if you are a researcher or an FDE guy, that's a different thing. And if you're a researcher applying this to internal insights, you're a data scientist. Okay, welcome to that title. But it's that simple. Essentially, you either ship code, or you clean data to ship that code, or you manage infra to ship that code, or you decide who this code impacts. It's as simple as that.
Right. Interestingly, there was a book written some 2 decades back, I believe. It was called The Inmates Are Running the Asylum.
Okay.
And it spoke about the fact that why do you need engineers in the first place, and why do you need product managers in the first place?
Mm.
So the core idea that they were trying to propagate was that engineers somehow have this tendency to be able to build the product and see if it works fine or not. The essential nuts and bolts of building a product, right?
Mm.
So I am going to build the product, but I really don't know or don't understand how the product would be consumed by the user, or if at all the product is required by the user, right? And that's when people understood that there is a need for somebody called a product manager, and product managers were brought in, and those are guys who basically go down and collect requirements, meet with customers, understand the pain points, do focus groups, user interviews, do whatever it takes to understand what is the actual pain point, and then, like you said, cut down the bias and come up with a set of value propositions or features that could that could basically cater to the problem.
Mm.
Now, having said that, over the last 2 decades or so, talking about India particularly, we have seen a lot of internet companies popping out, right? Fintech and all. So the product manager position became a very hot position, and it was not required for you to know, or maybe be a very techno guy or something and understand the nuts and bolts of technology. As long as you were able to understand the customer pain points effectively and communicate the same to the engineering team, you were good, right? So in a very deterministic software world, which I was a part of, I've been there in this space for like 20, 22 years. Product managers would basically tell engineering teams what to build or what not to build, right? There was a lot
I think
of
the more of the focus is on what not
to
to
build, right?
Yeah.
I mean, the feature death cycle and all we have seen over the years, right? But now, ever since the generative AI, the models appeared, right? Everything seems to have changed now, right? Um, there is a person called Dr. Marley Naika who talks about something called an AI development life cycle or AI development product life cycle management and all those things, right? So a lot of engineers or a lot of product managers rather, who were basically doing these simple product roles. The idea was to basically understand customer requirement, interface as much as required with the customers to understand what they really want, and then basically push down the feature, get the feature done, do an acceptance testing and all that, and then ensure that the feature is delivered, right? That was what was happening. They seem to be in a state of chaos now, right? Because suddenly everything has become so technical. For somebody like you who has already been doing it for a decade or so, things are easy because you've been doing it. So, and it's something like it's very experiential. The more you do it, the more you learn, right? But for folks like them who were product managers or senior product managers or even product leaders, right? There is a sense of paranoia, there is a sense of fear, or there is a sense of that, I really don't understand what's happening, man. This AI model, everyone's talking about tokens, ye token kya hota hai, stuff like that, right? I keep hearing this from a lot of product leaders. So somebody who was very apt in crafting a product strategy is now confused about crafting a product strategy because the person doesn't understand the non-deterministic nature of these so-called products. And now we have seen in the last 3 years, we have seen 3 different generations of products being rolled out, right? First you had models, and then you had like the wrappers over models, then you had native AI agents and all, and then now you're getting into the part where you're talking about insights and all that agents are basically doing for you. In this constantly fluctuating world, what would a product manager do, or what should a product manager do to stay relevant? Because now the question is of relevance. Are you relevant or not? And that's where I see a lot of fear and paranoia. That product managers are not sure what to read. There is an information explosion on the web. I don't need to tell or talk about that. But they are at this crux where technology is changing rapidly. Every single week or two, we have a new model coming up, a Chinese model or an American model, or even an Indian model for that instance, right? What should a product manager do to stay relevant?
Yeah, that's a good question. And I've actually thought a lot about this, interacted with a bunch of really smart folks. And here's my take on it. See, uh, so fundamentally, if you look at things, right, I like to view this world in terms of cycles. Everything is so. There's a saying, right? Like history does not repeat, but it sure rhymes, right? And this is one of those axioms that you just have to accept because you can't really prove it, right? But if you look at it, right, when my grandpa was there, right, that time, if you look at it, he used to listen to this transistor audio radio, right, and there will be BSNL Chowka connecting India, right? That's how he used to get his cricket sports. And right now we log into Hotstar and we're just saying, okay, number of viewers coming up, right? So has the information changed? No. The medium to translate that information has changed, right? If you go not a long back, just 20 years back, 10 years, like when we were in high school at that time also, right? You used to flip magazine pages horizontally, right? And you used to say fake movie stars, fake lives, right? Today, what do? You scroll Instagram vertically and you're saying like fake people, fake lives, right? Again, like the same social dynamic, the same things just propagate, right? The medium changes, a lot of technology, a lot of policies, a lot of adoption, back and forth happens. It doesn't happen directly. Like rarely would you see everything happen overnight. Like today, I woke up and no more TV on this planet. It doesn't happen like that, right?
Right.
In a very same way, jobs change, and what do you expect from those jobs will also change, right? So if you look at products initially, if you go back to those TV ages, right, we didn't have product managers, but we did have managers then, right? What did managers do? They used to look at this TRP ratings of their channels and their episodes, right? Then later on, this fancy product and growth titles started coming up, and what did we see? We were like, okay, how many DAUs are there, MAUs are there? What is my click-through rate? What is my engagement rate? Metric changed, right? In a very similar way, when you used to write product spec, not a long, let's say 5 or 7 years back, right? You used to write instrumentation spec, right? You used to tell, okay, this is what I want to track. This is what I don't want to track because this is how I'm going to create my funnel. Now, what do you track? Now you track evals. Because when you look at AI age, right, the core product of AI is intelligence, right? The core user experience of any AI tool is intelligent. So now you have to look at the UI. How does that UI behave? Because if no matter you have the best UI, right? If the answer is dumb as hell for the context that the consumer is in, you create a bad user experience. End of discussion, right? So now the job is, can you evaluate what my model will do? So one of the primary jobs that I see of product managers would be writing evals. It's not going to be engineers. Engineers' job is to meet those evals. And that's where I say the boundaries are blurring, right?
Are evals same as acceptance tests that used to exist?
Yes. Yes. That's how we should look at it.
Can you give an example of evals?
Okay. So let's look at it this way. There are a lot of metrics, right? So for example, you are looking at let's say mm, you're going to create a data set of different kinds of questions. Okay, let's say I created a model, and not just okay, let's be honest, I did not create a model. I took OpenAI API. Okay,
Right.
and then what I did was I created a fancy UI that wrapped that API and created a chat agent. That chat agent was created to serve only one thing: people who really love samosas, nothing else. Now tell them everything and anything about samosa in context of samosa. Obviously, this is a stupid product, but I'm giving a hypothetical example.
Sure.
Now, the thing is, when you have that chat, right, you need to understand how this model works. Model only knows the context of that session. Every conversation that you do is all that model knows. Think of it this way: you woke up and you have this chat, and after this chat you're dead, and then you're born again, there's a new chat, right? So there's a lot of clever engineering that goes, that kind of caches all of those conversations and that adds it into a context and pipes it back, so that when I woke up automatically a download happened, and sometime I got a new memory. Hey, in my past life I had this 24 conversation with you. Hi Saurabh, what do you want now, right?
Happened
So
with me
yeah,
recently.
so model never knows, at least the models that we have today, they don't know anything beyond the context of that conversation, right? Which means in this conversation, if and I'm a user, I know this is for a samosa, but I'll say a jelly bean are very salty. Now, what's the job of an eval? The eval is to measure statistically under certain distribution conditions that how will model respond to this question, because this was a chat about samosa. You wanted to say anything about samosa, good things, but you never wanted the model to prompt, to give an output of, are you dumb? I'm talking about samosa. Why the fuck are you bringing jelly beans? Right? But there is a finite possibility it might say that. And again, I'm taking a very extrapolated example, but essentially it is defining what not to do, what behaviors your model should not replicate. That's where the evals come in. So you create these acceptable, like you used to create acceptability test when you were defining a product spec. Now you have to create evals. Thing with evals is there's a lot of mathematics that goes into it, right? Because and it borrows from this very fundamental principle of statistics, law of large numbers.
Right.
So a very good example for any even non-technical folks to understand is when you flip a coin, you say the probability of heads or tail is 50-50%, right? So flip it 3 times, you might see 2 times it's coming tails, once it's coming heads, right? So that's not 50-50, that's two-third, right?
Yeah.
So is the probability wrong? No, there's a law of large number that says if you repeated this in a long sequence, then that probability would converge to 50-50 when you average out that sequence. What does that tell you about events? When you're out, so most of the people when they're testing tools like Chat GPT or any other tool, right? They're like, okay, I typed this, I got this response. This model is no, that's one sample. You need to run that trial over like hundreds and thousands of queries. You need to see exactly in what cases this model is behaving, how is it behaving, is this the output that I want? Okay, I put a guardrail, do this, don't do this. But in these cases, it violated the guardrail. It did not. So by what degree did it violate it, right? That is the process of evaluation. And when you say evals,
How do you
write,
manifest that? Is it like you write deterministic software to take care of that?
no,
Or is it like you manually do it?
no. So evals is a lot like benchmarking,
Sure.
right? So when you create benchmarks, what do you say is, okay, I'm creating a set of inputs, I'm creating set of outputs, right? And then I'm creating a statistical measure around this output where this is acceptable, and I'm creating a statistical measure. If you cross that bound, it is not acceptable. Now this is my set. I'll give this entire set to you once. I'll record all these scores, but this is just one sample. Now I'm going to run multiple trials of this and see how many times you stay consistent. I'm
Sure.
going to get average out score. So with if the output comes like 95%, it is aligned on racial bias, right? That means whatever your definition of racial bias was, it's aligned on that 95% of times. There's still 5% of time it might fail, right? And that is the core job now as a PM. That's one of the key jobs. It was much easier when you were writing instrumentation specs because you only had to define one event. Hey, if this clicks, throw this event. I'll put it in my dashboard as a funnel. Now things are not that black and white, right?
So yeah, in other words, edge cases were easier to handle back in
Yeah.
the deterministic software world.
Yeah.
But now, assuming what you just said, now thinking of it from a customer perspective, right? Let's say I'm a customer interacting with a bot,
Yeah.
right? And I'm supposed to basically ask the bot all the questions, and maybe there's an agent that helps me do a lot of things and all.
Yeah.
In that situation, if I get something really untoward, something displeasing, something that I'm not supposed to get as a customer, what do you do in those scenarios? Like, what is it that a customer can report at best? You can report that if I got this particular thing. And this is an edge case. You spoke about the 5% cases where you would probably get a very, very unpredictable output or something like that. How do you deal with those eventualities?
Oh, so that's the worst part of it, right? You can't deal with those. You live with it. You can't, right? So the only way to deal with this again brings me back to the initial point. The boundaries between what's product, what's engineering is blurring. Because the only way to deal with these kind of things is to take feedback, right? So in earlier products, we have this notion of NPS, right? And
Net
then
promoter score.
yeah, that's the same thing you do, but here it's RLHF, right? So you're saying, hey, good answer, bad answer. Tell me this much. I can't take a thesis from you as a user, right? Now, that particular session and its context and that conversation and its corresponding eval, based on that up and down, forms a template. take it. Good bias, bad bias. Now when the training cycle happens, the improvement cycle happens, the fine-tuning cycles happen, there are different ways to do that, right? Like depending on what scale and what purpose you're doing, you put that in again. Now you create a new set of weights for that model.
Okay,
Push it
so
back again.
before you get deep into that, for the sake of our product guys who are oblivious to the intricacies of these large language models,
Yeah.
what is pre-training?
Okay.
What is inference? What is post-training?
Okay.
What is fine-tuning? And anything else you want to talk beyond that?
Okay.
Make it simple for them to understand.
Okay. So start with a clean slate. That's pre-training, right? I gave you 1 terabyte. 1 terabyte is a conservative number. You usually have 15 or hundreds of terabytes of data at this point, but yeah, I gave you 1 terabytes of data. Okay, now clean this data, train a model. This model is blank, all the weights are zero. 1 parameter or 1 million parameter or 1 billion parameter, doesn't matter. Everything is zero.
What do you mean by weights exactly?
So think of weights as the position at which a dial is set if this model could be translated into a panel with millions of dials. So
Knobs.
each knob. So if I've set this knob to this knob to that, this knob to this knob to that, that's the weights.
Okay.
Right? Because this I have set it in a particular way, and now the circuits will behave in exactly that way, and you'll get that output. Right? So that's what the weight is, right? To be very not technical, very simple.
Sure.
It's essentially you adding bias on that model. So imagine like if two people are sitting and like you bring your friend in that conversation, you really hate that one person. You know, yeah, this person, I don't like this. You gave that person a bias, right? Now he'll behave in that way. Essentially, that's what you're doing with these models, but you're not giving hate as a bias. You're training it for the objective of your problem.
But how can bias optimize the output?
Everything is biased, right? See, we as humans classify things as good and bad.
Sure.
But arguably anything is bias, right? Anything, any perception is bias in its rawest, most natural form.
So that's the axiom of truth.
Yeah, right? And that's the whole point. In these models, when they're blank, they're dumb. They don't know anything. With bias, they're dumb, but with your bias. Think of it that way, right? But only thing is, this bias is what you call weights. Mathematically, bias is something even different. It's weight plus bias.
Weight into activation plus bias.
Yeah. So y equals mx plus c. It's a function, right? You shift it on that axis. But then again, this whole of that thing aggregates into this one weight, right? For a very simplified version. And that weight essentially tells where exactly is this knob set. That's bias in very simple ways, right? Not the bias of racial bias or that kind of bias, but it's the mathematical bias that tells what am I talking about, right? So that act of setting those parameters up is pre-training, right? That's when your model has reasonably reached a point that it can output something that can be argued as somewhat sensible, right?
Sure.
But and it's one of the costliest step, right? Massive scale, the bigger the model, right? You're usually spending about 10 to 30K per month on a GPU cluster if you're looking at that kind of a model that you have, and then it kind of runs for months on end, right, to finish that. Once that pre-training happens, starts the next step, which is post-training. Post-training is very important. Now, what's happening in post-training is your model is set. Now you are reinforcing certain attributes in it, right? So think of it this way. A couple of years back, people were talking about fine-tuning, right? And there was only distinction. Big step, 80% job, pre-training, 20% job, fine-tuning, right? Now that fine-tuning is now, say, 5% of the job. Pre-training has become 30% of the job. Now that fine-tuning itself has expanded into this new subset, which is post-training, where you're doing a lot of reinforcement learning and kind of really tuning it out. Now you're not tuning the basic fundamentals, right? Now you're tuning out exactly the kind of behavior you expect it to have, right? So think of it this way. how you train a dog, right? Like if it does something good, you're like, hey, take this cookie, take this treat. If something bad, you spray water on it, right?
Right.
That's essentially what you're doing over
Sure.
there, right? But again, easier said than done. Like it's very complex mathematical process. But to understand, that's what you're doing. Good doggy, bad doggy. That's what you're doing to a model. And again, based on that, it's just shifting those knobs very slightly somewhere, or some knobs are completely being flipped
Right.
because of that. Right?
Right.
Then comes the next step when you're saying fine tuning. Right? And now in fine tuning, what you're saying is, okay, everything is done. Now this model after pre-training, post-training is ready. But this model now knows how to talk and it knows English. But I wanted to follow this one customer support script. I wanted to follow this one refund process script, right? So when you have to really optimize it for one particular nuance, that's when you start doing fine tuning of those models, right? But fine tuning does not really give you any result if you have not done good pre-training and post-training, right? And when that bit is also done, then comes the user experience layer of it. That's when you start doing prompting and start giving it some examples. Okay, speak exactly like this. So think of it this way: when you brought your buddy into the room, you're like, always say Sir G to him, otherwise he gets mad. And
Right.
then he will talk in exactly that way.
Right.
So that's the final last step, right?
Mhm.
But that's what all these stages are. And evals come at each stage. So that's the most interesting and
So you're
scary.
saying evals happen at the pre-training stage?
Evals happen
Evals
at
happen at the inference part?
see, you are evaluating a model, right?
Mhm.
All of this was training. Now,
Sure.
once this is done, right, you take this weights, you deploy it, right?
Mhm.
You're like, okay, this is my software. Input will come in, it will pass through those weights, it will give you this output. Now I'm not changing these weights in real time. Again, I'm talking about the models and technologies that exist right now. There is some work going on where during inference time also these models would evolve, but right now none of those things are in production, right? So inference is when you have done all of these steps, you've done fine tuning and everything, you put this model up, you have multiple sort of backends, VLLM and all those things, right? You deploy it, and what you're saying is take this model, fit it into my GPU memory, the VRAM, the gold in this age. You put it over there, and now every input that comes in, I'm going to push through it. It's going to spit out an output. I'm going to give you this output. So this sole act of deployment, that's inference. And what's happening is, as the market is building more and more conviction, as we're getting better at evals, as we're getting better at all of these steps, and also optimizing this Pareto curve around the economics of this AI, which is a whole other can of worms, right? You're seeing more and more adoption grow. And what happens with more adoption is, earlier the problem was pre-training and post-training was expensive. Inference was cheap because no one was really using it. Now people are using it, right? If people are using it, inference cost is blowing up the roof because that's where the majority of the consumption of these GPUs is happening, right? So inference is different, pre-training is different, post-training is different, fine-tuning is different, and then prompting is different, right? And you have evals at each layer, you just call it differently. So you hear the word benchmarks a lot. That's when you talk about these different layers. When you have standardized evals, benchmarks are nothing but standardized evals. Again, massive data sets, handcrafted, designed optimally, thinking how would they be run on these models, how would statistically we would assess them. A lot of like, so in not even in AI, even before this whole AI gold rush, you used to have this thing called experiment design. Anything was experimented, right?
Right.
And even in product, you have that A/B testing. You have a null hypothesis, you test it out. And that's what A/B test. So the primary fundamental of A/B testing is you test out a null hypothesis, right?
So null hypothesis and then alternate hypothesis.
Yes, and then
Things
you
are,
test it out,
and then you
right?
test
Like
it out.
depending on the P score and T square,
Null,
depending
nothing
on
changes. This is
yeah,
like an alternate thing. This might change
exactly.
and all that.
So it's the same thing you're doing again, but in a different context with different parameters. But the fundamental is still the same. It's
Okay.
experiment design in the end, right? So that's what's happening. This is now more and more of an experimentation field, and less of standard playbook. I'm going to type this. This is going to be output. No,
Makes
doesn't work
sense.
like
Makes sense. You spoke about all of that, but you did not speak about RAG. I keep hearing about RAGs. I keep hearing that RAGs is better than fine tuning and all, and none of it makes sense to a product manager who's oblivious to
Yeah.
how these things work. So let's hear a little bit about RAGs. What is RAG, first of all?
So again, RAG is also a very marketing bloated word. I like you had RAGs even before you had AI.
Sure.
Okay, right. So before, I mean, think of it very simply this way: how does Google search give you a website?
Index. The index was RAGs.
That's what it is. RAG. Only thing is the models are different, the softwares are different, the way you use them is different. So now you're vectorizing that data set in a very different particular way. You're chunking it in a different way. Okay, I can't bring all of this thing in context. And like I said, like I gave you that example, right, where I am only alive in that one span of one conversation. I don't exist before that, I die after that conversation, right? So in that context, how do you tell me what all has happened, right? If these are small things that can be systematically plugged in by very good string additions and all of those things, but if this kind of needs to look into a very big repository, I can't be every time training my model again and again, right? That's where RAG comes in. You kind of put this whole vectorized index data set somewhere. It's like, okay, take this thing in because this is important for this conversation. You put it in that context. I now know about that conversation. I'm having that. It's a retrieval process. It's an information retrieval system. That's what it is. Let's not blow it out of proportion. It existed before. It still exists today.
Mm-hmm.
Right? It's just taken a different shape and a different flavor of hype.
So in today's world, if you look at agents like ChatGPT, they have the ability to take your query or prompt that you put there and search on the web,
Yeah.
come up with whatever they find,
Yeah.
and then maybe parse it and transform it and optimize it to basically show you the best result. Right?
Yeah.
That's what it does. So is this an is could this be called or classified as an external RAG?
Oh, so there are two things that are happening when you do that.
Mm-hmm.
Number one thing is prompting in itself is a very special thing, right? People just kind of take it for granted. Okay, I wrote some text, now model is giving me output in this way. But what prompts are actually doing is they are applying a tiny target. So think of it this way. These knobs exist. Now around these knobs, what you would call mathematically as your loss landscape or weight landscape, right? You apply a very specific target in that region. So what you are essentially doing is you're activating a very certain way this knobs would behave.
Mm-hmm.
Right? You're activating a very preset configuration that we don't deterministically A to B mapping sort of way we understand, right? But you are activating that tiny target, right? Now from that perspective, I am looking at everything. That's what prompting is doing. So prompting itself is a very special thing. We take it for granted, but the underlying mathematics of it is very fascinating, right? And recently a paper came out, I think yesterday I shared on that group also about so a bunch of Google folks said ki, why do models starts behaving better with few short examples, and it's as if the model was fine-tuning it in real time. It's a fascinating piece of mathematics. But so that happens, and then it says, okay, for this I have this information, but I also have something called tools, right? Now one of these tools is go look up something in my data set.
Mm-hmm.
Right? So that lookup process is RAG. How do you retrieve information and then pass it back into generated? So that particular flow is RAG. But there are other tools as well. So you go through multiple stages, right? So right now, these tool calls are also not linear. They're very graphical in that sense. Okay, first tool call will kind of trim it off all the sensitive data. Second tool call will kind of translate it into exact what kind of parameters it wants to kind of look in this RAG chunk and whatever things are. And then based on that, this information is passed into RAG. It kind of goes in, but then this input again goes back to that same chain, kind of filters it out, passes for sensitivity, and then does all of that, and then it kind of creates an input that the system has generated on you as a user's behalf, but the model doesn't know it yet, right? So model is still woken up and it just received a question, passed it on, it died. Now again, it woke up and all of that information has come to it as if it was part of that same conversation, as if you sent it to it.
Right.
And now it has kind of parsed it based on that personality prompt and everything. It's like, okay, hey, this is your answer, right? So, like the engineering side of it is really clever, really fun, right? But yeah, that's what's happening. So there's this another concept of tool calls that's important, right? And that's where a lot of new protocols have come up, MCP and all these things.
So would you say that, like, whatever you just described, would that be, or I'm not sure about what to call it, but is it also like an orchestration layer where different agents inside ChatGPT or a Gen AI tool are interacting with each other using their own tools to kind of get results as
Yeah, I mean,
necessary?
think of it this way, right? Like when you had deterministic software, you wrote APIs for different areas to contact.
You did.
Right? Now you write tools.
Okay.
Tools just wrap those APIs into a format and into that pipeline where your agent can retrieve and interact with it. So APIs were fundamentally written for other softwares to call, or for humans to write a software and then call it. Tools are written in a very particular way that an agent itself can invoke. That's what's happening.
So in all of this, where does MCP appear? I've been hearing about MCPs all over the spectrum of the
MCP
internet.
is just like, so when you had API, right, you had different formats. You had REST, you had gRPC, different standards around it, right? So OpenAPI had its own standard, OpenAPI 3 and all of those. So even these API had different standards on how would you write those API contracts, right? MCP is just a standard of writing this contract of a tool. So it's a JSON LD schema where you define exactly how my tool would be kind of. So there's a certain prompt element to it. There's exact function. There's
so what does it
path,
really mean in a very condensed, easy to understand way? What does MCP really mean? I mean, we know that model context protocol, and we're talking about all of that. But if a product manager who's not very technical has to understand what MCP is, how would you condense it to a form which is easy to understand?
Okay, so think of it this way: for every model, you had to create custom functions, custom way to write code, and then for every functionality, you had to write that integration in that specific way before MCP. Now, what MCP does is every model talks to MCP protocol in exact same way. Every function you write talks to this protocol in exact same way. So you only change the function and it's just plug and play. It's standardization, the way HTTP and REST and all of these things standardized, right? It's an interoperability framework. So think of it like USB-C for models.
Right.
MCP is USB-C.
Okay.
So if this device has USB-C, it will connect with any other device that has USB-C.
Right.
That's what MCP has done essentially. How do you take these functions, which are tools, and how do you have an agentic model that has been reinforced to actually call tools in a very efficient way? How do you connect them without every person coming up with a new way of writing this, new way of writing that? No. MCP. It talks in one way to models, it talks in one way to tools, plug it in, plug and play. You swap your models, still same. You swap your tools, still same. So now each tool can be created as a microservice. Your architecture becomes more scalable, more manageable, and all of those things.
So is there also a way where when these models can talk to each other? Like we talk about Claude and we talk about, is there a scenario or a system or a possibility?
So the model can never talk to another model unless there is a communication layer, right? So essentially what's gonna happen for these models to talk, you are going to create some sort of a tool, some sort of a agentic wrapper that takes this output, and then that output becomes input to this model. So you'll have to cascade it in one way or the other, right? So models, at least again, I'm talking about the architectures that exist today in production, because there's a lot of work in research around that as well.
Sure.
Right? And even in post-training phase, it does happen, right? Like pre-training phases, like there's this whole idea of distillation, but that's not exactly a model talking to another. You make them talk in one fixed way. Agents talking to agents is a different thing, because there is also another protocol coming up, which is not that mature friendly right now. A2A, the protocol that Google came up with, I guess something IBM has also come up with something on that effect. Not really mature, not that well adopted in the community as MCP is. But MCP is about tools talking to model. A2A and these are about this entire agent talking to another agent. So think of it that way, like tools talking to tools or something like that. Right?
Makes sense. Makes
But
sense.
they have not really gained the popularity. But there's nothing that makes model talk to another model until unless you manually kind of cascade them when you are deploying the inference or something.
So agentic AI typically is that ecosystem where agents are talking to each other to achieve a task. Is that what how you term it?
Oh, so agents and agentic AI are two very different things.
True.
Okay. So when you talk about agentic AI, you are talking about these models that have some sort of agency in them, and they are reinforced and trained and optimized. The architecture behaves in a certain way that they're really efficient in deciding which tool to call. Right. So the model itself has some sort of that intelligence trained into it. That's agentic AI. When you create models in a particular way and then you hook them up with tools. Agents is more of a software piece that wraps everything together. Right. So two very different things. I talk about agentic AI, and most of these terms are very abused these days, right? But agentic AI, especially like at least in scientific communities, it always talks about models that are designed and optimized and fine-tuned and reinforced and trained to behave that way. That means these models have some sort of differentiable memory to that extent that allows them to do these things more efficiently, and like a lot of very subtle nuances go into it. Agents talk about, okay, how do you put these things together so that as an end consumer I'm talking to one very smart system, right?
Right.
So your agent may or may not have an agentic AI inside of it. Like that's the most simplest form, because you can do a lot of clever engineering on top of it and still call it and pass it off as an agent. But agentic AI is fundamentally different, and agentic AI is a very growing field right now.
So we we've spoken a lot about engineering, but there is something that we haven't spoken about.
Okay.
What is that underappreciated thing, right? That is never really appreciated if you strip away the glamour and the hype and everything. What is that underappreciated thing in AI engineering that actually makes a product work? We don't talk about it. We don't mention it. It does not get the amount of recognition it should.
I think DevOps. I mean, most people would say data cleaning, and it's true. It's really like still today, data labeling, data cleaning, data gathering is still 90% of the work. You take it for granted, but when you have to build something, you don't have the data, you really realize what that means.
Right.
But uh, even with that, I think DevOps and just your old school engineering, like I think like the moment this whole agentic, agents, AI, generative AI, and everything came up, like people forgot it takes years and years of engineering finesse to actually deliver a product that runs reliably, right? Your SRE practices, the way you write your system architecture, the way you're writing these contracts, those things don't go away. And I hear this like a lot of time, like engineering is dead. Engineering is dead. No, it's not. You need more than ever now, because these
Absolutely.
systems are insanely unreliable. Who makes sure these systems are up when you're having a coffee and you're just like putting random data in it? It's giving you content for your PPT, right? Like you want that PPT in 2 minutes. You got it. How did it happen? It's because like there was some engineer who was up all night trying to figure out why is this stack overflowing right now, right? So I think that because AI gets this lot of hero persona, I think people have forgotten how hard it is, and on the same time, there are other profiles that people sort of have forgotten, but are even more important. Like for example, your QAs. You take away a QA from the entire development life cycle, and you'll have a shitty product before you can start spelling shitty. Right? So QAs are still very much important, right? Always the argument is with generative AI, these people will become obsolete. No, they're not. Because the work is increasing 10 times than what it was. And the tool is only enabling them 5 times to be that productive. So now you have that 2x demand of those folks, right? So they're important. And even with your product managers right now, right? If you kind of take away PMs from this whole cycle, then you're going to end up with systems that. So one of the most interesting things that I think today, a PM that's rolling out an AI product has more to say than less, because the economics of AI product is insanely hard to crack. It's absolutely insane the
We've
rate
been
at
talking
which.
about it like for a while now.
Yeah, and these systems cost like, I mean, like a simple training job, and I'm not even talking about inference at this point. And when the growth hits, and then there are a lot of eval scenarios. So balancing all of those things, and then making sure the entire kind of ship goes on track, shipping better and better feature, not crappier and crappier feature. So I would say there's one profile that does not get said a lot. I think between all the fear, uncertainty, doubt, and hype as with all cycles, people are getting carried away. In a while, this will all settle it down, and once it does settle down, you'll have a lot of shitty systems in production that people need to fix, and then people with strong fundamentals at each of these distinctions would come in, and this will be their job to actually be the janitor of this whole hype cycle. So I would say one job is more important than the other, but I think, detaching yourself from the hype cycle and coming back to the fundamentals and just accepting, okay, my job has not changed. My job is still there and it's important. How do I solve? Okay, as a PM, I need to fix my evals. I need to solve my economics. That's what I'm going to focus on. And I'm going to figure out how do I do this NPS thing, which we took for granted in SaaS world, but now in AI world, and do it better so that that reinforcement cycle is better. As an engineer, I want to make sure this model kind of statistically behaves in this particular way only in this particular eval cycle, but it does not blow up my inference cost. So what kind of flags do I set? Do I need co-located compute over here? Why am I buying a co-located compute when I just need to do inference, right? Those kind of decisions they need to go into, right? So everyone has their role, and the QAs. So I think the most hard job would be like, and yeah, I think QAs would be impacted the most, because the transformation or fundamental skill set required is going to be most in QAs, because the core expectation from QA is going to be more and more on do those evals. The system that the engineer has designed, the evals and PMS set, who's actually doing those evals? Who's going to measure that statistical validity of those evals? There's going to be a QAs.
So would you say a PM is going to become a QA in some ways?
Yeah, the lines are going to be very blurry
They'll
between
merge.
growth, PM, QA jobs,
Sure.
right? And again, lines are going to be very blurry between ML engineer, AI engineer, and data labeler or cleaner, that kind of a thing. I know labeling is a different thing, but yeah, also on labeler, because labeling is going to be more and more system generated. A lot of synthetic evals are going to come up over there. That part of eval is something that engine is going to take care of, not your products per se. So a lot of things will change, but still stay the same. And there's this one domain that's, I think, gonna face the blunt of it. I mean, no shade, but if you look at the past 5 to 10 years, right, every nook and cranny you see a digital marketing agency, right? Every company is a digital marketing agency. Like, most people kind of just jump to that, right? And that has been serving well, right? Like, since the whole economy was ad, you do 2 clicks, and and, a lot of creative and insight goes into that. But then in the end, you're building your model on top of ad economy and SEOs and stuff, right? But now one fundamental shift is, earlier you used to design websites for humans to visit, and for web crawlers to crawl. Now your user is changing. More and more agent will do work on the user's behalf. That means the way you design your ads, the way you design your websites, the way you design your product, right? You have to think of AI as a user, because agent is now going to be my proxy user. So I'm not going to be going through your 100-page report every day. I'm not going to be clicking through 2 pages, filling out that form and getting that data. I'm going to ask my agent, hey, give me that report, I have a meeting, right?
Sure.
That means if your website is not accessible to agents, if your products are not accessible, so ARIA was a very common standard for human acceptabilities, right? I think we'll either see a standard that comes up corresponding to agent, like we had ARIA labels and those kind of things, or we would see agents kind of build on top of the infra that ARIA and all of these things are laid out, which means I'll most of so more than 30 to 50% of websites on internet are WordPress sites, right? And that's where most of the redesign work is gonna come in, because you're gonna have to kind of rethink from scratch. And people think just writing llm.txt does it. No, it does not, right? You have TDM rep, you have JSON LT schemas to go, and you need to write the right schema in the right place. So a lot of work is gonna go over there. Probably some frameworks will come up that will make this job easier, but then again, it's like first mover advantage, right? So are you going to wait for a new framework to come, or are you going to do it yourself for your website, so that by the time it comes, you're up in that index list and you get more domain weight and those kind of things, right? So I think if like the lowest hanging fruit that's ripe for disruption is this whole SEO and ad piece, because we just look at it, like in the past 5 to 6 months, 15% of Google clicks have vanished. Like,
Yeah.
that number speaks volumes,
Yeah.
right? And now your brand is just some parameter in some LLM somewhere, right? You're not a link on a page.
Right.
So things will change. It's the same thing, right? You flipped pages.
Also, the fact that a lot of internet is now behind paywalls, right?
Yeah,
Earlier, we had like content available to everyone, right? You could
yeah,
go to an NYT and you could browse the content or browse as many articles as possible, right? From what you're saying, there is a chance that the marketing landscape is going to change drastically, right? I mean,
fundamentally.
fundamentally, right? I mean, and there'll be a different way of distribution that will come up. Today, also, if you see the digital marketing landscape, you have SEO, you have SEM, and you have email marketing,
Mm.
you know, you have all kinds of social media marketing and stuff like that. But there might be a tectonic shift from what we have today to that particular thing, which is
Yeah,
what you're saying, right? Now, switching a little back, we all talk about compute. It's like one of the favorite topics
yeah,
in multiple groups that I'm part of, right?
yeah,
Everyone talks about it, just like everyone talks about strategy in India, but nobody understands it.
yeah,
Similarly, everybody talks about compute, but nobody understands it.
yeah.
So when you say compute, what do you really mean? Now, answer it for a startup that wants to launch an AI product, right? What does it mean for that startup?
Yeah,
Now, also talk about the cost of compute. We keep talking about that compute has gone down. We keep talking about Jevons paradox. We keep talking about a lot of stuff, right? But first of all, what is compute with respect to a model or an AI product you plan to build? How does compute go up? The simple calculation I have on the web is that input tokens into number of price per token plus output tokens in multiplied by price per token, all of that multiplied by the number of calls. That's the simple math behind it. But if it comes to cost per se, if you have to compute a cost as an entrepreneur of running an AI product for your consumers or your customers, what does that mean for you?
Hmm. So, see, this is one of the most. So this talks about that, like I told you, right? Like the whole product and engineering leadership, the lines become blurry, right?
Mhm.
And then one side of it is eval, the second side of it is economics of AI.
Right.
right? So this kind of deals with that economics of AI piece, because compute means different at different stage of your AI life cycle, right? So think of it this way: as a startup, right? You are already building SaaS products. I'm assuming that for that person, I'm trying to answer at this point,
Sure.
right? Uh, you either host your own SQL server in some LAMP stack somewhere, right? Uh, or you go to AWS and
That's
you're
what
like,
people do. Yeah.
yeah, you're like, give me an EC2 instance and I'll
Instance. Yeah.
deploy it over there.
Yeah.
Or you go to AWS and you're like, just give me an SQL instance.
Mm-hmm.
Three different approaches, right? When you go to AWS and say, give me an SQL instance, right? That's a managed instance. So you're going to pay premium for it, but then they're going to do the entire database management for you, right? You're just going to configure how you want to use it. You have that endpoint, you take it up, and then you kind of partition it the way you want it, use it, you rewrite it to it.
Right.
The second approach is you're saying, okay, don't give me a managed MySQL, just give me a managed compute rack. I will put my MySQL on top of it and then manage it myself.
Mm-hmm.
And the third is when you say, like, don't give me anything, I'll set up my own rack. I'll host it over there.
Mm-hmm.
So there are three ways, right? The way you looked at MySQL is the exact same way you have to look at models, right? The only thing is your model does not fit into your memory in most cases. And that's where things start blowing up. So think of it this way: most startups have very unnecessarily complex database designs, right? Almost like every startup that I've seen. Um, I, I don't know, like there's this some sort of jolly people get just trying to use the fanciest new technology they have heard of, and you don't even have a need for memcache, but you are deploying a memcache instance. It makes no sense, but okay, you want to do it, go ahead, your life.
Sure.
Right? Ruin your startup. Well, I don't care. But the point is, even when you look at most sensible startups, right, who, because see, like the entire GitHub scaled with Postgres, right? Entire Instagram scaled with Postgres. Like it was after they hit a massive amount of scale, that's when they said, okay, I'm gonna start diversifying this whole architecture piece, right? But some people are just putting microservice after microservice, hunt this DB for that, this DB. That makes no sense. In a very simple, similar way, if you look at the way AI landscape is there, right? People make it unnecessarily complex there as well, right? Some things are very straightforward. If you want to host a model, deploy it on a VLLM backend. For most, like 90-95% use cases, a VLLM backend would serve you. Put it over there, select which model you want to deploy, GGUF, put it up on one instance, live. Problem happens when you are selecting which instance, because your model needs to fit in your memory. And it's when this model does not fit in that memory, you have complexities. And I'll tell you why these complexities emerge. So even with legacy systems, right, you have this CAP theorem, right, of distributed data sets. And it comes from this fundamental limitations of physics, right? Like there is a cap at which how fast the speed of light moves, right? And we take internet for granted, but internet is just like bunch of transatlantic cable routers hosted this way, that way, a lot of servers. So data is moving packet to packet from one continent till you can see that meme in your screen. Like it takes multiple packets routing multiple optical fiber throughout the entire planet to come to your screen, right? Now what happens is that it's not instant, it is near instantaneous. And when your data is distributed at more than one places, if you're serving from one place and some other place gets updated, you have a state where these 2 points are inconsistent, even if a slight point, right? That's where the chaos effect starts happening. right? That's why it's always best advice to put everything in one table and be done with it unless you really need to distribute it. Similarly, with the models, the complexity start arising when they don't fit in that one memory, and that's when you need to start looking at, okay, how do I connect all of these hundreds and thousands of GPUs? What kind of interconnects I do, and all of those things, right? Now, most of these complexity as a startup founder, you don't need to worry about. People start worrying about this, but you shouldn't, right? Unless you are pre-training a model, you don't have to deal with it. These because pre-training is a different ball game. Tell me how many startups are really pre-training their model. Let's be very honest. If you want to talk about marketing, that's okay. I can bet like 90% of startups don't even understand what pre-training is. And why do you need to pre-train? Like if you're there to solve a research query, then probably yes, you really need to for some use cases. But for most startups, you don't need to worry about pre-training, post-training. You just need to deploy a trained model, right, and build the whole infrastructure scaffolding around it to serve your customer. So that's one thing. But even in this case, managed SQL running on EC2 instance or my own rack, these three options exist. My advice for any startup right now is like, don't bother, just pick up OpenAI's API, prove your business model, get that thing working, and then figure out why do you want to shift. Because people talk a lot about using open source, but people forget open source is not cheap,
Absolutely, I agree.
right? So think of it this way: when you're saying you're going to deploy an open source model, what you're really saying is, I'm gonna put up my own EC2 instance on one of these providers, right? Like be it our team at Aeon, or say you have this Navius, or you have CoreWeave, or you go to AWS or wherever. You say, oh, give me an instance. I'll put up my model over there, and then I'm gonna serve that endpoint as an API, and then I'm gonna do whatever I want to do with it. That's fine. But for most people, you don't need that because you don't understand the kind of challenges that go into it. Because it's not that you just serve a model, it will start giving you the same result that a chat GPT or an OpenAI API or Anthropic API or Mistral API, so managed API would give you. There's a lot of caching going on. There's a lot of guard railing going on, a lot of different ways you do lookups. The it's so it's one of those things where you take for granted how hard it is to go from 90 to 99%. It's very easy to come to 90%.
Yeah.
Right? And going from 99 to 100 is even harder, right? But the moment you say you're going to manage everything on your own, you are unwillingly taking that thing for granted or adding that burden to you. So as a startup, I would say just take any API tokens you can get. Do the economics of input token, output token, prove your model, get that thing out. Once it is out, once you have enough resources, now you think about it because it's going to be a full-time job managing an instance. That's why managed instances are paid in premium, right? And once you are comfortable with that whole landscape, then only move to this bit. Then only move to previous step, which is post training and then pre training. A lot of startups just like love to make flashy announcements and they jump to all of those things, but you don't know what you're signing up for because they're interconnects. You need to know exactly which kind of interconnect you need for which purpose, right? You need to know, okay, if my demand is going to be X, how much of horizontal scaling do I need to do? How much of vertical scaling do I need to do? Right? Now, on top of that, different regions have different availability. Those availabilities matter, those pricing matters. Why? Because see, in the end, compute is not magic. It's some data center running somewhere. Cost of electricity is directly proportional to your data center cost, which is directly proportional to how costly that GPU is going to be. Now, what are you going to do? You're going to model every country's cost of electricity as a startup. You're opening a can of worms that need not be opened for most startups.
True.
right? It's very unpredictable that way. So there's cost of electricity that goes into it, and a lot of factors that go into it that define, okay, this is what my GPU will be priced at. But then based on demand, those GPU prices may change, right? And then also based on availability, not all GPUs are same. Say, let's say you have certain set of nodes that are not connected with InfiniBand, but then you have certain set of nodes that are definitely connected with InfiniBand. So with InfiniBand, you have much better interconnect. But then obviously you are losing some bandwidth of that GPU that's going on just on interconnects as well. So it's a different can of worm. And my advice to basically any startup is don't open it unless you really need to open it. Stick to existing APIs, use it. They exist for a reason. Once you prove your use case, only go to managed inference instead of saying, okay, I'm not going to take open APIs API. I'm going to take some provider that's just managing a fine-tuned model for me. Then you come to the next step where you're saying, okay, give me an instance, but you better really know exactly how much of that vertical scaling you need, how many nodes you need for horizontal scaling. Then you host it, you know which backend needs to be there, VLLM or whatnot, right? How do you set those right flags over there, right? Because then you're entering in that ML ops territory from that point on. And once you are comfortable with that and your demand really needs you to move to the next step, that's when you start going to fine tuning. That's when you start going to post training. That's when you go into pre training. So you really need to know why you need it. And even at this point, you need to model your customer's demand, right? So, for example, if you have a spike, how would you scale up those nodes, right? Or can you afford downtime? Like, not everything is mission critical. So maybe you can afford that.
Right.
So again, like I said, right, like the product role starts becoming very blurry between evals and economics of AI, because in your traditional sense, it was a straightforward mathematics. Here it's not, right? Because even the query type is not so. We talked about compute in general over here, right? And then also this file storage, networking, the different elements to it, right? You literally talk about a data center business at this point. But even if you take that aside, if you look at the demand side of it, right? So when you are running a typical software, you are putting in certain query, right? You know exactly all the APIs that would be hit. You just need to model how many hits would be there on that API, right? And you compute the demand on it because it's all deterministic. But now, depending on the product, maybe your agent has a graph, right? So now, based on this, the input prompt can be of any length. So number of token has already varied, right? But then based on that, it's going to trigger different state of this agent graph, and that's going to trigger different retries on that agentic query. So that individual query itself is indeterministic, the amount of load. So you can always get that estimate to an aggregated viewpoint, right? So now demand is also varying, the whole supply side is also varying. It's a can of work that you need not open. So as a starter, simply focus on taking any existing either managed API or the API that already exists. First build your model around it, prove it, get demand and see what sort of demand you are getting. If you have that number very clear, then you see which step do you need to really jump, and jump only one step at a time. Otherwise, you are touching something that you're not prepared for.
True, true, true. I think that explains a lot why a lot of AI startups are failing now, because the economic is something that is not sustainable in the longer run, right?
Yeah.
But now that you've spoken a lot about AI engineering, I would love to move to one of my favorites, which is the cognition part, right? So let's talk a little bit about reasoning models, right? I mean, we have graduated from language models to now
Yeah.
reasoning models, and now today almost every model from Claude 4 to ChatGPT 5 and even DeepSeek R3 to some extent, I think they're all able to reason as well as a human being. I wouldn't say as well as a human being, but I'd say almost close to human reasoning. I mean, of course, I would definitely upset Daniel Kahneman if I say that reasoning models are basically reasoning as well as human beings. But again, this gradual shift to reasoning models, has anything really changed in the way the architecture was deployed earlier for language models?
So,
How is it reasoning basically? To be honest, if I were to.
okay, so again, there are two kinds of system that exist today systems that are being worked on, right?
Sure.
Systems that exist today are not reasoning per se. It's an illusion of reasoning, right?
That's the Apple paper.
Yeah.
That's the Apple paper.
No. It's not about the Apple paper where they actually benchmark those numbers. I'm talking about in the general sense, because reasoning today is basically when you get certain set of tokens, you're classifying first set of token as thinking tokens, and you've reinforced your model to give certain initial set of tokens as a high level plan. And then using that, you generate next. So in the end, from start to end, they are tokens only. Only thing is, my UX is showing you those initial set of tokens as thinking. That's it, right? So they're not reasoning. First thing.
So it's more or less the same thing.
Yeah, it's
Except for
a
the
UX that makes
UX
you
has
feel
sort
like it
of
is reasoning. It's not really reasoning. Only thing is, it is taking more time. You're given more compute resource at inference time to generate token, and the depth at which you want to generate it based on the query. But that's not really reasoning per se. But then you have this whole anthropics biology of LLM seminal work that came out, right? Where they came up with very interesting, so they performed literally lobotomy on their Haiku 3.5 model, right? And where they realized, when even with this kind of approach, when the model is actually reasoning, quote unquote, in the UX sense, right? Model has already thought of the answer even before the first token came out. Most of those tokens are going into convincing you that, hey, I actually thought about it, right? Which was a very interesting paper. And to be honest, like, anyone in this field should really, really read any and every bit of noise or even a sound that comes out of Anthropic's team, because they I think, are doing one of the most fabulous job in kind of giving us insight of what's fundamentally happening around these systems, right? Interesting work. But these newer architectures that are being explored and worked on, there, I think reasoning is being fundamentally explored, right? So if you look at reasoning, right, you need to classify what is reasoning, right? And to a certain extent, reasoning involves some sort of planning exercise, right? So you are essentially varying temporal scales around which I have to look at a problem space and generate my output, which you call as strategic thinking. Okay, what I'm going to do next, what I'm going to do 10 steps from now, and how this should converge, right? So this is a temporal scale of next 2 steps. This is a temporal scale of next 10 steps, and somewhere down the line, these are meeting, right? That temporal variation in architectures like Coconut, continuous chain of thought, that came from Fair Meta Lab, right? Or even with this whole SMG architecture of Mamba and all of those things. That's where the models are really being trained to actually think more in their latent space even before outputting the first token, right? Also, a new paper came out which was around HRMs, hierarchically reasoning models, right? And they also kind of replicated two functions. Like, so there's a higher level thinking function, and lower level thinking function, and a higher level thinking function is working on a broader temporal scale, and a lower level thinking function is executing on a shorter temporal scale, right? And these two systems are communicating with each other. That's also quite resembling of reasoning to an extent. Also, this I think in terms of reasoning, the most interesting work was done primarily by AlphaGo's team with their famous move 37-bit, right? But then that approach has still not translated into these kind of architectures yet. So maybe we are yet to see something on that end. But I don't think there's like a silver bullet on reasoning. It has been unlocked or it is to be unlocked. I think a lot of these components will come together, right? So along those lines, the Facebook's Meta Lab is working, I think, fundamentally with their whole architecture of VJEPA. So it's not just the VJEPA is a unique architecture, but the way they are creating it is, okay, video encoder is VJEPA, but then this part is this, and they're trying to kind of bring it all together like you have in brain, your frontal cortex, your occipital nerve, and all of those things. And There are different areas that kind of communicate with each other, but all have separate roles, right? And I think memory was a big problem, but we are moving towards a space where memory is mostly solved in these kind of systems. But and if not, it will be solved in a few years. But these things will come together, and we will for sure see really good quality reasoning models. But in the systems that exist today, you have a UX that makes you feel like the system is reasoning, and on the engineering front you do give it extra inference time, compute to think longer, but it's not reasoning per se. It's just same token,
Mm-hmm.
just putting it on a loop,
Right, right,
right? So
right.
so those systems are not
So
reasoning.
all the while I was thinking that this model is actually reasoning it out while it's showing me that, you go to Manus or any of these different engines and they'll basically tell you that, hey, this is what you told me and I know I'm doing this and this.
That's just really good guardrail that you're saying.
Hmm.
That's
Because
really good guardrail.
it keeps telling me all that it's doing. You gave me this. Now it means that I'm supposed to do this, and this is
Yeah,
how I plan to do it. So it gives me an entire thing, but that might not be the way it's actually doing it. The
yeah,
tokens are already produced even before it reasons anything.
yeah,
But there's no reasoning per se, right?
yeah. That's the best part. So it's not like these systems are exactly like your linear chats,
Mm-hmm.
but then they are not reasoning per se. They're just like spewing out more and more tokens and feedbacking on those tokens themselves. It's not reasoning fundamentally, right? Because to reason, also it also deals with the how you define those terms, because reasoning to a certain extent implies your certain thought in abstract thought spaces, right? And these models work on tokenized spaces, so pure by mathematics they can't reason, right? If you go by those that vernacular definition of reasoning, like
So there is a baseline fact or basically an axiom of truth on which you basically reason, right? Your
yeah.
reason is associated with that. It's predicated
So
on top of
so
that.
reasoning essentially implies there is a chain of abstract ideas, because see, so again there are two schools of thought over here, right? So you, one side you have Jeffrey Hintoff's school of thought, where he said like models can still think in tokenized spaces, right? It's just a
Mm-hmm.
matter of scale when you'll see emergence of real intelligence coming in. And then the other side, you have Jan LeCun's school of thought, right? We're saying like reasoning and human level intelligence fundamentally requires thinking in abstract thought spaces. You don't need to necessarily think in tokenized space, and those abstractions kind of lead up to one another. And that's where you see like most of Fair's papers like Coconut and Vijaba, they follow that kind of an approach.
Mm-hmm.
And the rest of the industry follows more of this approach. Like even like some of his, and these are they are all his students, by the way. That's the best part, right? That's why he's godfather of AI. So even Ilyas Kabir and all, they're all a student, and they follow like a very different school of thought. They're like, oh, it's just transformer, 10x the data, 10x the reinforcement learning, 10x the compute, and you'll see better result, better result. You keep making it bigger, 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 bigger. They have a very different approach. But in both these approach, today we are not reasoning, but we might get there. And that's the funny part with AI. You can't predict when it's gonna happen.
True, and I think if you listen to a lot of what Jan LeCun talks about,
Yeah,
I think he says that LLMs are stupid.
yeah,
He says that LLMs will never achieve AGI.
yeah,
You cannot achieve AGI through LLMs. AGI is an altogether a different concept per se. And even on the Kardashev scale of intelligence, right? I mean, assuming that human beings are at a level one, type one
yeah.
intelligence, they're pretty backward from, let's say, somebody who's at level five or levels, maybe an extraterrestrial civilization located far away from the Earth and all that.
Yeah.
But even when we talk about AGI, there has to be the concept of consciousness, right? If you talk
Not
about
true.
a sentient system, might be able to. So when I talking about synthetic, creating synthetic intelligence, I'm not just talking about language model per se, right? I'm talking about, let's say, a humanoid, right, which can behave
Okay,
almost
so
like us.
here I want to understand from you,
Hmm.
like, do you think intelligence fundamentally comes from consciousness? Because now we're venturing in a philosophical domain, and so with most of these conversations, what I find is lacking is uh, you don't have same uh, stick to compare both the metrics, right? So essentially, either we as a humanity agree intelligence is a function of
It's not,
consciousness.
because from all, if you look at evolution per se, there are a lot of organisms that do not have consciousness, but they have intelligence,
Yeah. See, whenever it comes
or
to
vice
the
versa.
topic of consciousness, right? Like I am usually very
It's something. Let's not deviate into
uh,
that territory, because it's uncharted territory and a can of worms we shouldn't
yeah.
open, right? But having said that, if you if I talk about the simplistic definition of AGI that we are all talking about, with different kind of perspectives coming from different schools of thought, right?
Mm.
What are we trying to say out here? What does AGI really mean, or what does super intelligence mean? Because if I read Nick Botston's book, he talks about super intelligence. He
Mm.
talks about, and Elon Musk has endorsed it, and so many other people endorsed it. So he talks about the, let's say, a Skynet, right?
Mm.
We've all seen Terminators, right? I mean, they were my childhood favorites back in the 90s. But is there a remote possibility that at a certain stage of singularity you would have intelligence that will surpass human intelligence? And I'm telling you that because if you have seen that video where AlphaGo played the game of Go with
The move
uh,
37. Yeah.
Lee Sedol, right? And he kind of it won them five times out of six, right? And Lee Sedol, the unbeatable champion of Go, was completely taken aback because he had never expected the random moves that seemed stupid at first
To
were the
come
game
together.
changers,
Yeah.
right? So if you talk about those abstract moves or those abstract things that machines can see that we cannot as human beings, we don't see those patterns. Do you see? Do you feel that at some point, what Musk is worried about, the complete annihilation of the human race and all those things, which seem a little bit sci-fi or dystopian to speak of, that they would kind of happen. We would reach that stage where machine intelligence takes over. And let's talk about AGI. Let's not even go to ASI. Do you think AGI systems will basically help us do all that we are doing at a very intellectual or a mental level, so that we don't need to use much of our mental faculty to do much of the work that we do? And there is going to be a system. I remember there was a Bruce Willis movie where there was a system that would basically go to office to work on Bruce Willis's behalf and do everything that he does, and again come back home. So he does not have to go anywhere physically. Are we approaching that singularity, if I may use the word singularity to describe it? Or is it mostly an element of sci fi, mostly like a Black Mirror episode, best forgotten?
Yeah. So I mean, see, there was a time when I used to kind of laugh with disdain on such theories,
Mm-hmm.
right? Uh, the more I spend time with these systems, the more I question each behavior, more I understand. See, I'm convinced today we have competence without comprehension. That's where we are.
Mm-hmm.
So if you talk about today, there's nothing to be worried about, right? But then the point is we're not talking about today. So humanity's own worst enemy is not going to be AI, but it's going to be human, right? These systems are going to further the biases that already exist, and these systems are going to work towards the objective function that we provide. If we underspecify, see, if you have a bug in a deterministic code, you can debug it to a certain extent and you can fix it. I mean, what's the worst that can happen? You're talking about a bug in something that we don't understand today, right? Everyone understands how these systems work, right? We created those algorithms. We know exactly the kind of functions we gave. We just don't understand what happens after those weights are formed. That's when that black box starts, right? And we still don't know it, right? There's a lot of work going on in AI explainability. So now this question is fundamentally talking about comparing two mathematical trends, the rate at which the compute is going to grow, the rate at which these models algorithmic capabilities are going to grow,
Mm-hmm.
the rate at which the compound effects is this going to grow. And Then after certain point of time, inside that black box, will you have competence without comprehension or competence with comprehension? Because if you have furthered the biases the way they are today, and you get to a point where it has competence with comprehension at that scale. See, let's be very honest. I think in one of his so Sam Altman is a very hypey person. He creates a hype a lot. But I do agree with this one statement: a child born today will never be smarter than AI. The rate at which a child will grow and the rate at which AI will grow, we will come to a point. A child born today will never see a time in his life where he's smarter than AI. It very well might occur, right? But then smart with comprehension, smart without comprehension, that's a
It's
very
debatable
yeah,
because contextual. It's very contextual. I think.
yeah,
What do we mean by smartness?
yeah. So that's this whole thing, right? Like it's fundamentally a debate about intelligence with comprehension and the intelligence without comprehension, and what essentially defines comprehension, and does awareness has a certain component to it. And then again we come back to that whole consciousness debate, right, which is a different kind of work. But even if you put everything aside, AI is getting dangerously close to being at a point where we can barely control it other than just shutting the servers down,
Right.
right? It's not there yet. And what worries me more is not that AI will get there or not. I work with a lot of smart folks. And the scariest thing is, a smarter the person is, the bigger his blind spot is, right?
Mm-hmm.
So sometimes we think like, hey, this person is not even educated about AI. How he's saying random things about movies and whatnot? Like, why does this make sense, right? And you're like, okay, I train these models for a living and everything. I know this is nothing but statistical algorithm and everything, but that's the thing, right? Smart people tend to get tunnel vision, and we start like the synology over there is like, a frog being boiled alive. You don't even realize it's happening when you are in that rock, right? Like if it's in a hot water, if I throw you, you'll jump out. But if I slowly ramp up the temperature inside it, you won't even know when it's happening.
Yeah.
And that's the scary part when you look at compute trend, algorithmic trends, and the fact that we already don't know what's happening inside of it. And then you put world's smartest folks on it. You have a situation and you're being boiled alive, and you are essentially sitting and debating on these hypothetical scenario. So on that end, yes, I do have a very high p doom figure, right? It's close to 80% probability that might happen. Personally, I do perceive that, but it's based on these factors. And so there's this interesting series of Isaac Asimov Foundation,
Mm-hmm.
where this Harry Seldon, he creates this whole tool, mathematics branch called psychohistory,
Mm-hmm.
where he said like, you can't predict the future, but you can with certain amount of accuracy predict the fall and rise of civilizations, right? And it's a very interesting novel to read, but
What novel is that?
Foundation, it's a series, Isaac Asimov,
Isaac
like,
Asimov.
yeah,
Yeah.
the three laws of robotics. So over there he had like the zeroth law, and
Mm-hmm.
some robots would come and all that. So again, these are very good intellectual exercises. The point is, we don't know what's going to happen over there, and the scary part is people who are making these policies know even less. That's the scary part, right? Because in the end, everything's kind of governed top down. In the end, the individual voices don't matter, and so the bias, the trends, and the lack of understanding at a policy level, we very well might head to that scenario. I won't be shocked.
Now, moving a little bit towards product management, I think there is a question that I came up with. I basically use models to create those questions, if I may. I think the question is very interesting. It says that in a world, in an AI first world, is the roadmap still driven by user needs, or is it increasingly driven by what the models can do?
Hmm. Very interesting. So I think here this whole idea
So
of
the second part of this question is even interesting, even more
okay,
interesting. The second part is that what if there is a scenario where the product requirements clash with the model capabilities? How do you make that trade-off? Latency, cost, hallucination, whatever.
the product requirement clash with model capabilities.
Yeah, there could be a scenario where the product requirements could clash with model capabilities.
Well, plain and simple, you can't build it. Yeah. Like you then you are saying like engineering needs to
Exactly,
delve
which
into
takes us to the
research
first
domain.
question.
Yeah.
So the moot part of our question is over here is that in a world increasingly driven by models and what models can or cannot do, right?
Hmm.
How important are customer needs?
So I think here
Because
now there are two opposing schools that every and this would be like a very personal exercise for every product manager as in what sort of product manager do you want to be. But there are two school of thoughts. On one end you have Elon Musk and where you are saying make your requirements less dumb. Rule number one, right? On the second end, you have Steve Jobs' school of thought, where you're saying your customers don't know what they want till you show it to them, right?
Mhm.
So, depending on the kind of product you're building and the kind of product manager you are, you want to be, you have to find where do you lie over there. And this, I think, talks to the soul of what is product management. You're trying to create something really beautiful that does not exist yet. Right. So it would be a very personal call, right? Do you want to push folks
but
to do more
isn't
research
the
or
entire
come more
objective
realistic?
of product management revolves around customer delight, right? I mean, you would want to do something that will make the customer happy, right? I mean, at a
Yeah, but
psychological
then that's
level.
the thing, right? You don't know what. So again, two school of thoughts. You
Mhm.
don't know what your customer really needs,
Mhm.
right? He may say he wants this, he wants this, but it is unless you have manifested something to him
Mhm.
is when you really get to assess does he really like it or not, right?
Agreed.
Everything else till then is a hypothetical exercise,
Hmm.
and you create a lot of models and frameworks to get to that point. But ground truth will always be your customer feedback. That's not going to change, right? On the other end, there are limitations to what you can do, and you need to figure out clever ways around it, right? So that's why I said like that. Or there will always be these two school of thoughts, and just because AI is advancing, the fundamental way of approaching problem won't change. Either you make your requirement less dumb, or your customer doesn't know what they want yet.
Mhm.
And somewhere between that lies your answer. It's going to be a very subjective call on the particular context of the product and your customer and the kind of metric you're trying to hit. Right?
But wouldn't that be a little unreasonable when we basically are trying to tell the customer this is what your need is based on our model's capabilities?
No, we're not saying this is what your need is based on our model's capabilities. What we're saying is, hey, your problem is you want to read magazine. We're just giving you a better way to read it. But how better can we give it to you is dependent on a function of our model. So till a model gets better, right? We help you flip pages, but when it reaches a certain point, we help you scroll on that feed.
So essentially, all we are doing is adding a layer of efficiency over it, right?
Yeah. And I would say instead of looking at it that way, you
So
are adding a
let me
layer of
put an
efficiency.
example. Let me
You
give an
are
example.
taking away a layer of inefficiency.
You spoke about flipping pages, right?
Yeah.
And then instead of flipping pages, you spoke about, let's say, getting a notification which explains everything. And then think of a dystopian scenario where it's directly coming to your brain through brain waves. That's the last part of
Yeah.
development, right?
Yeah.
So are you saying that this is what that I need to basically give you all of that if I were to make you happy?
Yeah. I mean, at some point, economics also matters, right? Like, so you have to weigh into that account. But think of it this way: earlier, you had knobs, physical knobs for everything, right?
Right.
As the technology improved, you came to screen
Mm-hmm.
with only fixed set of keyboards,
Mm-hmm.
right? Technology became either better, your input became only a touch. As your technology even becomes better, you're seeing like the interaction space is reducing.
Right.
The possible space and degrees of freedom in which you could have interacted is reducing because you are coming more and more closer to how humans naturally interact. And isn't that the whole idea? The technology, you should not learn a technology. The technology should blend into the way you interact with each other. So that's always going to be the natural evolution. Right? We just have to kind of expand that temporal scale in which we view this evolution. That's where you have to figure out, right? Like maybe a customer doesn't even know, they simply want to communicate, right? But because the brain is conditioned to communicate, I need to press a send button. So they're talking to you, oh, make that send button bigger, bigger, bigger. But then if you can take away the whole concept of send button, then what's better, right?
Now, moving a little bit towards the end, I think it would be fair to cover the future of AI engineering, right? I mean, we spoke about AI engineering in detail. You were patient enough to explain all of that, the nuts and bolts of AI engineering. But if I were to ask you that, what is that one engineering bottleneck, if solved tomorrow, would unlock a massive leap in AI applications? What would that be?
Hmm. I think there are two areas that I think are very important. One is some sort of a compiler for AI, right? So AI is not a compile time thing, right? It's just in time. But if you can figure out new architectures in which AI systems are compiled instead of being interpreted, then I think that would open a lot of doors in terms of optimizing how
Would you
those.
expand on it a little bit? When you say compile,
So so
what do you
so
mean
so
exactly?
look at how your typical binaries are built, right? When you look at C, C++, or those kind of systems, right?
Sure.
And so all the errors are mostly caught at compile time, right? And it gets,
Syntactic analysis and all that,
yeah,
right?
and
Yeah,
then you can get some sort of a finite automata out of it
out of it.
that kind of behaves in a very particular sequenced way and gets kind of cached in those instruction set in a very particular way, right?
Right.
So there's a very high level of control and observability on those systems, right? AI doesn't behave that way because its nature is fundamentally different, right? So
It's
it's
NFA mostly.
yeah. So it's always that dilemma which is going to question more and more around reliability of those systems, right? Because obviously, like it's basic mathematics. Like deterministic is always more reliable than non-deterministic, unless you can find that non-linear dynamic bound in which there's that stable equilibrium. But then again, you are venturing in a field of mathematics in a black box that's not yet invented, right? So that's one problem over there, which because any high quality product essentially depends on reliability of that output. If you can't make it reliable, it doesn't work. Simple, plain and simple, right? So that's one area. The second area I think is there's so much to do and there's so less time. So the faster you can go from an idea to an execution, if that turnaround time can get smaller, you get to iterate more and pick the right one. Because if you are in a non-deterministic era, then the best way is run more trials, right? Then that's the
Right.
second approach. But to be able to do that as a human, you can only write finite amount of code. You can write finite amount of specs at a certain time. So now what you're saying, or you're bringing multi-agent observability platforms that are writing code instead of you writing code, and you're essentially creating that symphony. Okay, this agent is doing this. Okay, it's happening this way, and you're kind of mixing those things together, right? So the Claude code and all these tools, they're just the beginning, and they break. You can't trust them, their output and all those things. But again, you're looking at like a very nascent stage of this thing. As they evolve, you're going to come at multi-agent development and observability scenarios, which kind of will fundamentally transform how you actually write code, right? Instead of writing code per se, you're going to write how do you orchestrate the swarm of agents that's deploying it, and instead of debugging, you're going to be focused more on the observability of these agents so that you get those certain kind of outputs out. And as that bit gets more faster and economical, by the way, because it's really expensive. You can do that now, but it's very costly, right? Even 1 hour of that kind of a multi-agent session, if you spin up, it's going to easily cost you 340 $500 like that, right? So it's expensive. So it has to become economical and more stable to do that. But once it happens, I think that there will be massive unlock with what one developer and one product manager sitting together in 1 hour of session can produce. It literally, like the kind of startups people are making today can be 1 hour session of 1 p.m. one developer just sitting together in this multi-agent observability framework, just getting it out. So the idea becomes, okay, iterate on as many as you can. So those 6 months, 7 month, 12-year development cycle would shrink, right? Because if you can't have it deterministic and reliable, then run more samples of it, more iterations of it. So either of this, and then it depends on how this technology evolves. Maybe this side evolves faster and this kind of takes a backseat or becomes a component. It would be a fascinating thing to see. But I think as a developer today or as a product manager today, you really, really need to stop hitting agents and AIs. You really need to understand, okay, what does this unlock? Like you need to stop enforcing your human deterministic way of doing things on agent. You have to understand they have certain abilities you don't. Now take advantage of those. Right? You can't read 100 documents at once, so you created a dry coding setup, modular codes, and everything. But then agents work different way. They get confused and dry. They are really better at putting 100 things together. So it becomes very counterintuitive when you're saying like this elephant can't fly. Why are you comparing it to a bird? That kind of scenario. But that's where this is, I think, is headed. At least in the near few years down, long term. I don't know. No one knows.
So before we conclude, I think there is a very important question that a lot of product managers and a lot of software engineers, you yourself run a community of 1100 AI folks, right? They would like to know that if you were to talk about, and separately for software engineers as well as for product managers, a set of skills that they need to master to stay relevant in the next 5 to 10 years, what according to you would be those skills?
Um, to be honest, I don't know. Like the only
The earlier
answer
shelf life used to be 6 months for any skill.
right now, the only see that's the thing, right? The the pace at which the experiments are being run across industries and profiles is changing so far. The only skill that matters is how curious are you and how fast can you unlearn something.
Mm-hmm.
Like if I have to boil down to two things that will absolutely be needed is curiosity and the pace of unlearning, not learning. Like learning doesn't matter, you learn it this way, that way. If you cannot unlearn old patterns fast enough,
Mm-hmm.
then you are in big trouble, right? And being curious will already help you in that way. But if you have to kind of pick some particular very hard skills, uh, it's really hard to pinpoint. I think it all boils down to understanding the fundamentals of experiment designs. That thing is not going to go away. It's just getting it didn't go away when you did SRE, when you had to look at site uptimes and how do you model those behaviors, right? It didn't go away when you did product management. It came in A/B testing and all of those things. It didn't go away, and it's not going to go away with evals. It's not going to go away with multi-agent observability. It's not going to going anywhere. So experiment. It doesn't matter. You're a product manager. You're a software engineer. You are marketer. This that if you are not good at experiment design and statistics fundamentals, how do you understand the variance? Because you live in a probabilistic world now. Good luck.
It seems like a scary future because not everyone can adapt so fast. I mean, there are folks who are used to a certain way of learning, right, and are learning all of that in just one go, and then learning completely different, which might change or
Yeah.
flip, let's say, in the next 10 to 15 days.
Which is where the rate of unlearning becomes even more important than
Yeah,
rate of learning, right? You need to unlearn what you've learned really fast so that you can be blank and then learn what's new.
absolutely.
Right.
Uh, Thank you so much, Harsh. Thank you so much for being patient. Thank you so much for answering all the questions. I think we have extensively covered on all fronts: AI engineering, product management, and a lot of stuff around intelligence, which I'm personally fond of. And we keep talking about it on the group, we keep talking about it on the phone. But I personally enjoyed talking to you and learning about all these things. And I'm sure as this podcast goes out live, it will reach out to all the folks who are interested in understanding the nuts and bolts of AI engineering, or let's say the enigma surrounding it. This could be a great way to dispel all the myth surrounding AI engineering. But yeah, thanks a lot for coming and being a part of it. Really enjoyed having this conversation with you. Look forward to having you again.
Thank you, Saurabh ji.